Welcome to GOVidya. So in the previous sessions, we have discussed some important problems of control systems. Let's start the session. First question, root locus branches start from. Exactly, this is the basic question which are asked in the previous exams also. Basic question, directly you can put the option as open loop poles because poles is the point where the root locus is going to start. Let us assume a pole zero diagram, sigma j omega. There is a pole here and there is a zero here. So my root locus, suppose if the root locus is lying in this range between these both, then obviously my root locus should pass from pole to 0. So at this particular point, the open loop pole is the point where root locus is going to originate. So open loop poles is the right answer. Next question. The root locus of a control system shows the movement of closed loop poles when mainly root locus is going to depend on the gain. What is that gain? K. The value of K based on the value of K gain, which is K f of s. K f of s is equals to 0. We will have an equation 1 plus K f of s to prove that it is DRL or CRL. Any of the option. We are going to see that whether the system is going to get direct root locus or complementary root locus. The main option is this K. So what is that? K, gain K varies from 0 to infinity. Let's see other options. As we know the answer by concept, let's see other options also. Input varies from step to impulse. There is no option. This could be the option. Time varies from 0 to infinity. In time response analysis, we are going to concentrate on time. So this is not the answer here also. Frequency varies from 0 to infinity. In the part of frequency varies from 0 to infinity, students may confuse that these both options A also may be correct, but we are going to do the frequency analysis in the case of Bode or Nyquist or polar plot. So in that case, frequency analysis can be done. Frequency varies from 0 to infinity or any other point. So there it will be that answer. But here gain K varies from 0 to infinity is the answer. So whenever you see the root locus, its dependency will be on the value of K, gain K. Next question. The number of root locus branches is equals to. It is a simple question, not number of zeros. Number of poles, yes, this may be answer. Difference between poles and zeros. And number of asymptotes. Number of asymptotes, there is nothing to do with this option. Number of zeros, yes, students may give this as the right answer sometimes, but please don't get confused. Root locus branches in the sense, we already know root locus is going to originate from a pole and end at a 0, okay, or go to infinity. So at this particular point, you need to see that firstly this could be the right answer. 0 will not be the answer at all. And difference between poles and zeros. Students may get confusion that from Nyquist plot or some other plot, they will assume that this formula n equals to p minus z, number of encirclements or any other, they may get confused and say this could also be the right answer. But in the case of root locus, this is never the right answer. Only from the number of poles only, the number of root locus branches will be related. So the relation is how many number of root locus branches are going to be in a particular given transfer function, those many number of poles are going to be. That's it. Okay, next question. So this is one of the interesting question asked in electronics gate. So the root locus plot of closed loop system with unity negative feedback system and transfer function KGS in the forward path is shown in this figure. Yeah, in this figure we can see. I'll explain what is this. Note that K is varied from 0 to infinity. What does that mean? When something K gain is varied from 0 to infinity, it is nothing but root locus. We are working on root locus. Previously we have seen a question. So next, select the transfer function that results the root locus plot of the closed loop system as shown in figure. So we need to find what is the transfer function for the given particular root locus plot. Students may assume this as a complex problem by seeing the graph or by seeing the root locus. But trust me, this is very easiest problem. How? I'll explain. See, what is the distance between origin to this point 1, which is nothing but at this particular point, the point is -1, 0. So sigma is equals to -1 at this particular point. And you can observe from somewhere the root locus plots are going outside. Each of them is going outside and they are making around 72 to 36 degrees. Overall it will be 360 degrees, but there are totally 5 root locus plots, like 5 root locus branches. So 5 root locus branches at point -1 comma 0, 5 RL branches, okay, which is nothing but, as per options, if we are going to see, exactly at this particular point we are going to have 5 poles. So from previous relation, how many number of root locus branches, that many number of poles. At which point there are this many number of root locus branches, they are going out, which is nothing but breakaway point. This is acting as a breakaway point also. So at -1. So exactly by this we can say that our transfer function which we are going to get here, some value, some k or some 1, in anything, it could be anything. So and in the denominator we are going to get obviously 1, like s is equals to -1 is my root locus branches are 5. So at this particular point I am going to get 5 poles. So s is equal to -1. If s is equals to -1, how I am going to represent it in the denominator? S plus 1. And how many branches are there? 5 branches. So at this particular point there will be 5 poles. So by this we can say that sum of the option which is in this form, k by s plus 1 by 5, 1 whole power 5, or 1 by s plus 1 whole power 5. From this both only any option will be correct. So if we are going to see, A is one sort of option which would be correct. B, students will get confused exactly at this point only. It's not s power 5 plus 1 is equals to 0. This is the wrong option. S plus 1 whole power 5 is equals to 0. This is the right option. Understood? So this is not at all the right option. Next, s minus 1 by s plus 1 power, this is nothing to do with this option. And again this option also there is nothing to do with. So the right answer is option A. This is a simple question. Just you need to use the logic of root locus branches and how the relation between root locus branches and number of poles. As the previous question we have discussed, it is a similar application into this particular question. This was an excellent question asked in GATE exam. So be familiar with these kind of models too. Next question. A closed loop system has a characteristic transfer function of some equation is given. Its root locus plots against k. So here we can observe there are two different, like these both are similar and these both are similar. If we are going to crack particularly the pole 0 diagram and find the break in point or break away point, then without drawing the root locus only, sometimes, not all the times, sometimes to save the time, we can select the option easily. How? We'll firstly follow the steps, then we'll see what is the thing. So here, considering our equation, s square minus 4 into s plus 1 plus k of s minus 1 is equals to 0. This is our preliminary equation which is given. So we will convert it into 1 plus k f of s is equals to 0, so that we need to derive it DRL or CRL. So let us divide this whole on both sides. We are going to get 1 plus k into s minus 1 by s square minus 4 into s plus 1 is equals to 0. So this is my f of s. Every of the s variable has positive only. So what are we going to do? Like it is in the form 1 plus k f of s is equals to 0, where k f of s is equals to minus 1. So when k f of s is equals to minus 1, what is my root locus? Direct root locus. So directly we can proceed with the next step. What is the next step we are going to do? We are going to give the what are the number of poles, number of zeros. This is the second step. Then centroid, we are going to find the centroid, and third step after this we are going to draw the pole 0 diagram. Till this point we are going to complete the half of the root locus, constructing the root locus. These are the first 4 points. First determine the DRL, next find the pole 0 diagram, like pole 0, how many poles are there, how many zeros are there. Next plot the find the centroid, and the fourth one is we need to construct the pole 0 diagram. Okay, so from the equation we have what is the f of s? S minus 1 by s square minus 4 into s plus 1. So f of s is equals to s minus 1 by s square minus 4 into s plus 1. This is my equation. Exactly what we have f of s equation after simplifying that actual given equation. Next, from this, let us find the poles. What are my poles here? Firstly, s square minus 4 is equals to 0. S square is equals to 4. S is equals to plus or minus 2. This is one part. And s plus 1 is equals to 0. S is equals to minus 1. This is one of the part. Okay. So how many poles are there? Number of poles. Capital P. Number of poles are plus 2, minus 2 and minus 1. So 3. Next. Zeros. Number of zeros. How many number of zeros? S minus 1 is equals to 0. There is only one 0. So S is equals to 0 is the 0. And how many number of the capital S? Sorry, we can represent as Z. Z is equals to 1. Next, we need to find the centroid. So P is equals to 3 and Z is equals to 2. These both are the number of poles and number of zeros. Next, let us find the centroid. For centroid is represented by sigma. What is the formula? Sigma P minus sigma Z by P minus Z. What is this sigma P, sigma Z? Sigma P is nothing but sum of all the poles. Sigma Z is nothing but sum of all the zeros. So, from this point, what are my poles? Plus 2, minus 2 and minus 1. Let us add all those three. Plus 2, minus 2 and minus 1. This whole are the poles. These are the sum of my poles. And minus of, what is my 0? Here I have done a mistake, sorry. So my 0 is, S is 1. So exactly 1. Here it will be 1. And what are the P? What is the value of P? 3. Number of poles are 3. And Z is 1, 0. So solving this, 2 cancel. Minus 1 is minus 2. And 3 minus 1 is 2. 2 are going to get cancelled. Minus 1. So at this particular point, sigma equals to minus 1 is my centroid. So we have found the centroid. We have found what are the positions of the poles and zeros also. Now let us draw the pole zero diagram and indicate how the root locus is going to lie on the particular pole zero diagram. So at this particular point, let us draw this. So plus 2 and minus 2. So one pole 2, one pole minus 2. Another pole minus 1 and 1 0 is 1. Firstly, this system is not stable. Secondary, here there are 2 poles successively and 1 0 to 1 pole. What we know, root locus lies in DRL. Root locus lies in the odd poles and zeros, towards the odd poles. Seeing from this side, I have 1 2 3 4. So this part there is no DRL. From this particular region, 1 2 3 odd number of poles and zeros are there in this particular region after minus 2 pole. So here my DRL exists. Okay. Next, seeing from this point to this point, from minus 1 to 1, if we are seeing, then here also we have 2 poles. Combination of poles and zeros are 2. So here also DRL is not going to exist. And from 0 to this point, there is 1. So it is an odd. So again, DRL will exist in this particular region also. So DRL exists. And here also DRL exists. These both are the particular points where DRL exists. Next, let us see particularly which direction DRL exists. We know from one open loop pole, DRL is going to go towards 1. Why 1? Because it is a 0, open loop 0. So here our way would be 1 pole to 1 0. Okay, this is the direction of 2 to 1. So from open loop pole to open loop 0. But here also DRL exists. Here DRL exists from pole to 0. But here pole to pole how? So here when there is a case of pole to pole, we will have some breakaway point or break in point here particularly. Why? Two poles are going to go nearer to each other to the break in point. Let us assume somewhere between here we have a break in point. Not break in point, break away point. Why break away point? Two poles are going to come. So one from there, one from here. They need to go to some zero or to infinity. So here particularly, it may go like this and it may go like this. But like we will take the direction of this upwards and direction of this downwards. In that case, let -2 is going like this downwards and -1 will go like this upwards. So somewhere between here we will have this point is break away point, BAP. So break away point. So this particular, if any of the options till this point, we have drawn a assumed plot of root locus. If any options are going to match with this, then we are going to select that option. Else, if there is any more complexity, like two options are same but just the point is different, then we are going to see. So based on this approach, we'll see how the options are. So -2, -1, yes, both are the poles we got. 1 and 2 are the zeros, yeah, 0 to from open loop pole to open loop 0. My direction of root locus is yes. This option could be right. Option B, -2, -1, exactly. So it is going like this. Here also it is going outward. So this option also could be right. Option C, we do not have a 0 at -1. So these both options are wrong. But here if you could see, students may get confused that directly they'll put A option as the right answer. But no, observe the direction of the root locus. Why that root locus will not pass exactly to this point? Because if this is going to pass in this case, this should be my zeros, not my poles. But how my -2 and -1 are not zeros, they are my poles. So when poles, the root locus from poles, the root locus is going to travel towards 0, open loop 0, or towards infinity. So if you could see in the option B, from -1 and from -2, it is going towards the break away point BAP and going towards infinity or towards some open loop 0. So here the right option would be option B, not option A. Okay, in this process you can save some time fastly if you could do fastly, and you could directly select the options. If there is any complexity at this particular point, then directly find the breakaway point and proceed with the next step. Okay, let's go to the next question. So an open loop transfer function G of S of a system is G of S is equals to K by S of S plus 1 plus S plus 2. So we need the breakaway point, BAP. So what is the thing we need? BAP, breakaway point. What is the breakaway point? So what is the open loop transfer function given to us? G of S is equals to K by S of S plus 1 into S plus 2. Okay, let us write. Firstly find what is the is it DRL or CL? By seeing you can tell if 1 by K let this be f of s. So f of s, this is directly equals to 0, then this is going to be a DRL only directly. Okay, this will be a DRL only. What are we going to do is, from this particular equation we will determine the next the value of K, like the value of breakaway point. So from this 1 plus K f of s, 1 plus K into what is my f of s? 1 by S of S plus 1 into S plus 2. Okay, is equals to 0. This is the equation which we are using to determine DRL or CRL. But what I am doing is send this -1 here and make this K at it, like put the K at one side, and what is the other equation coming in the other side, I am going to put in that way. So K is equals to firstly 1 goes this side and it becomes -1, and whatever the denominator is there, it gets multiplied with that. So I am going to get minus of S plus 1 into S plus 2. So now to get a break point, any break point, what are we going to do? We need to differentiate the value of K and equate it to 0. At that particular point, if the equation, whatever the S value we are going to get, if it is going to lie in the area of root locus, like S, suppose we are going to get S some value as 4 or 5 or something. If that is lying in the DRL, then that is the breakaway point or break-in point of that particular equation. So next, let us differentiate this equation. Okay. k is equals to minus of s into s square plus 3s plus 2, and again multiply with this minus of s cube plus 3s square plus 2s. Okay, this is my final k equation. So after this, what I am going to do, differentiate dk by ds is equals to 0. After differentiating it, what are we going to get? dk by ds is equals to minus of s cube differentiation is 3s square. Next, plus 3s square differentiation is 6s. Next, plus 2. 2s differentiation is 2. This should be equated to 0. So however minus doesn't matter in this particular point, then we are going to get simplified equation as 3s square plus 6s plus 2 is equals to 0. So we need to find the roots of this particular equation. Okay, we got the equation to find the breakpoint in this particular case. So what is the equation? 3s square plus 6x plus 2. So the equation is 3s square plus 6s plus 2 is equals to 0. Let us solve this through normal algebraic equation method. So what is the formula? Minus b plus or minus root b square, which is 6 square, 36, minus 4 into what is my a 3 into c 2 whole divided by 2 into what is my a 3. Okay, so here I am gonna get minus 6 plus 36 minus 4 3s are 12 2s are 24 by 6. So s is equals to minus 6 plus or minus, and here 36 minus 24 we are going to get 12, and here 6. So solving this through by using calculator. So the options I am going to get are minus 6 plus root 12 by 6. So these are the options which we have got. No, students may get a doubt that why using calculator. In exams the calculator will be provided, else the scientific calculator will be provided if it is a CBT. Else this much calculatory sums will not be provided if it is an offline exam. So no need to worry. So these both are the breakpoints which we have got. But we need to know which breakpoint is right or which breakpoint is wrong. For that, what we need to do, we need to follow the first preliminary steps to build a root locus. What are my points of root locus? Like what is the equation? K by s of s plus 1 into s plus 2. So my g of s is k by s of s plus 1 into s plus 2. Okay. So after this particular point, we are going to do how many number of poles are there. What is the number of poles? 3 number of poles, and what are they? 0, minus 1 and minus 2. How many number of zeros are there? 0. So there are nothing. Let us draw the pole 0 diagram directly. Drawing the pole 0 diagram directly, sigma j omega. 0 is my pole, minus 1 is my pole, minus 2 is my pole. Minus 2, minus 1, 0. Okay. So same, if it is a DRL, odd number of poles exist, odd number of poles and zeros exist only in the right half of plane, then only the DRL exists. So here at this particular, seeing from behind of minus 2, 1, 2, 3, there are 3 poles. So DRL, here DRL exists. From this point 2, so DRL doesn't exist. Again from minus 1 to 0, there is 1 pole from right side. Okay, so here also DRL exists. DRL exists. DRL exists. Okay, these both are the particular points, but we need to see which breakpoint is correct or not. So minus 0.422, where would minus 0.422 lie? Maybe somewhere here, exactly here. This is the point where minus 0.422 lie. Next, what is next? The minus 1.577. Minus 1.577 in the sense somewhere in between here. minus 1.577. You can clearly see minus 0.422 lies in the between of 0 comma minus 1 where DRL exists, but minus 1.577 lies between minus 1 and minus 2 where DRL does not exist. So this is the wrong break point. 0.4 minus 0.422 is the right break point. So minus 1.577 is not the right. S is equals to minus 0.422 is the correct break point. It would be breakaway point or break-in point. In the question, he mentioned it as breakaway point. So already the point is breakaway point. It is mentioned by the examiner. But we need to find what is the break. As we got the answer minus 0.422. This is the right answer. Okay. Understood, students? Let us follow the next question. The gain at breakaway point of the root locus of a unity feedback system with open loop transfer function Ks by this some equation is given. Some transfer function is given. We need not find the break point. Yes, we need to find the break point. But what is the last outcome we need? The gain value of K at that particular break point. It is nothing but obviously we will find some break point like differentiating the 0. Okay. S value we are going to find. But what we need to do, that S value we need to put in the particular equation, this S, K, S of by this equation, and find the value of K. So that is the required solution for our problem. So K is equals to how much at breakaway point. Okay, that is the equation we need. Exactly. So let us follow the order. Firstly, first one, we need to see DRL or CRL. So what is the equation given to us? 1 plus Ks by S minus 1 into S minus 4 is equals to 0. So it is 1 plus K f of S. What is my f of S? S by S minus 1 into S minus 4 is equals to 0. So obviously this is the equation of DRL. So my equation is, my root locus is DRL root locus. Second step. Let us go through pole 0 diagram. So what is my f of S? F of S is equals to S by S minus 1 into S minus 4. Okay. Now what are my poles? What are my number of poles? Firstly 1, 2. There are 2 poles. And what all are they? 1, 4. And what are my number of zeros? 1, 0. What are they? 0. Okay. S is equals to 0 and 1, 4 are my poles. What is the centroid? Now we will find the third step. What is centroid? Sigma, which is sigma p minus sigma z by p minus z. This is the equation of sigma centroid. So what is sigma p is nothing but sum of poles. 1 plus 4 minus what is my 0? 1. Yes, 1 is my 0. Sorry. 0 is my 0. Which is 1. 1 0 is available. Okay, don't get confused at this particular point. And how many poles are there? 2 poles. And how many number of zeros are there? 1 0. So this 0 is my 0. Value of 0 is 0. Okay. So 4 plus 1 is 5. 5 minus 0 is 5. And 2 minus 1 is 1. So my sigma value is 5. Okay. So you can write it here. So sigma value is 5. So centroid will lie at 5. Let us draw the pole 0 diagram first. Then we will assume where the break point is lying. Then we will find out the value of gain at that particular, like before getting the break point, we need to see that which is the valid break point. So to get the valid break point, we will do this step. So from here, sigma j omega, and drawing it at this particular point, 1, 4. So 1 is my pole and somewhere here 4 is my pole, 1 and 4. And next S is equals to 0 is my 0. So here is my 0. Okay. From right side, so like from right side of every pole, we are going to see whether the DRL is existing or not. So coming from this side at 0, 1, 2, 3, there are 3 number of poles and zeros at the right hand of plane. So DRL exists at this point. Again after this there are 2, so it don't exist. And again between 1 and 4, yes, it exists. Between 1 and 4 it exists. Okay. So DRL exists, here DRL and here also DRL. Okay. So whatever the breakpoint we are going to find in the further steps, if it is existing between these both in these particular area, then it is a valid breakpoint and there we can find the gain K. else till that time we need not find the gain k. If no value is there, then we are not going to get the gain. Okay, now let us find the gain k. How are we going to find the gain first? Gain value, like breakpoint dk by ds should be equals to 0. Okay, so what is my k f of s? 1 plus k of s would be 1 plus k into s by s minus 1 into s minus 4 is equals to 0. From this I am sending 1 that side, so it become minus 1. And what is the k value? Minus of s minus 1 into s minus 4 whole divided by s comes down, so it becomes this. So this is my k value. So what we are going to do, we will find some breakpoint and substitute in this equation, and then see, like, to get the value of gain we will substitute in this, but before that we are going to see that it is a valid breakpoint or not. So here dk by ds is equals to 0. Differentiating on both sides here, like, we are going to get u by v. So minus doesn't give, there is no use of minus even though if it is there. So we are going to get d by ds of s minus 1 into s minus 4 whole divided by s. This should be equals to 0. Okay, so what is the differentiation of u by v? Like, I'll write here. So d by dx of u by v would be v u dash minus u v dash by v square. Okay, this is the value of differentiation of a by b form or u by v form. Okay, so this is my u and this is by v. So directly we substituting that, we are going to get s into differentiation of numerator. So what is the differentiation? Like, we'll resolve a step, d by ds of making it into a simplified equation, s square minus 4s minus s is minus 5s plus 4 by s is equals to 0. So let us differentiate from this point. So s, it is a v, and u dash, which is 2s minus 5. Differentiation of 5s is 2s minus 5. Next, after this 2s minus 5, u v dash. So minus u, what is my u? S square minus 5s plus 4 u v dash into u v dash. V dash is nothing but s. Differentiation of s is 1 by what is my v square? S square. This whole should be equals to 0. Okay, s square will multiply it by 0, so there is no value for that, and s is multiplied here. We are going to get 2s into s is 2s square minus 5s, and minus is multiplied inside, minus s square plus 5s, again minus is multiplied, minus 4 is equals to 0. Resolving this, 2s square minus s square is s square, plus 5s minus 5s gets cancelled, s square minus 4 is equals to 0, s square is equals to 4, s is equals to plus or minus 2. So I've got two breakpoints, plus 2 and minus 2, but whether I need to see, they both are going to lie in the DRL or CRL. So as we have DRL, we will see. So at this particular point, here somewhere minus 2 will be, and here somewhere plus 2 will be. Yes, both of the options are correct only. We are going to get DRL here, in both cases. So both are the breakpoints, but for this given value, we need to see what is the breakpoint, as per which breakpoint we are getting which option. Okay, so for s is equals to plus 2, put this value in, let this be equation 1, put in 1. Okay, so putting plus 2 in this equation, k will be equals to minus of 2 minus 1 into 2 minus 4 divided by, what is my s again? 2. Okay, here I am going to get 2 minus 1 is 1, 2 minus 4 is minus 2, minus 2 into minus 1 is 1, minus 2 into minus into minus, it becomes plus. So here I am going to get 2 by 2, which will be 1. So here my k value is 1. Again, next, s is equals to minus 2. So putting minus 2, similarly k is equals to, when I put minus 2 in this particular equation 1, so I'm going to get minus of minus 2 minus 1 into minus 2 minus 4 whole divided by minus 2. Okay, so minus gets cancelled, minus 2 minus 1 becomes minus 3, which is multiplied into minus 2 minus 4, 4 minus 6, and this becomes somewhere divided by 2, and becomes 2 1s are 2 3s are, so minus 3 into minus 3 becomes 9. So for one break point I'm getting 9, for another break point I'm getting 1. So as per the options, we need to see which is the break away point. So particularly I have said both of the points are correct only, but which is the break away point we need to see. So here from somewhere, some or the other place, from infinity, okay, from some infinity pole, I am gonna get this break point. My root locus would be like this, but it will be traveling in this way, okay, at this particular way. So this becomes my break in point, BIP, not BAP, break away point, not breakaway point. But here my root locus will travel till some break point 2, which is that 2. Here it is minus 2, here it is 2. So it will travel towards this particular point, okay, and it will go out from this particular position. In some other, it would be like this also, like this also. I'm assuming like this, and it goes away. So what is my break away point exactly? 2. 2 is my break away point. S is equals to 2 is my break away point, not S is equals to minus 2. It is the break in point. Okay, so both points are correct only, but which is the break away, which is the break in, we need to decide. So break in is minus 2, break away is 2. So what he asked for break away point, so plus 2, what is my answer? 1. So exactly for plus 2, my answer is A. So 1 is my breakaway point. K, value of K at breakaway point is 1. Okay.